I'm going to be talking about something that I get to have a half hour that takes at least 3 hours to cover. So be normal. If I go a little too fast, just try to bear and ask me later on if you have questions on it. But this game modeling, it's one that you got to be real careful with in the results. When I was back in the good old college days, which my case was quite a few years ago, garbage in equals garbage out on the modeling, and that has not changed at all. So with that in mind, let's just go through, and I'm going to give you some basics, and then we're going to get into some, we hope, ideas of what works, what doesn't work. And the modeling aspect itself is not going to be technical at all, because we don't have time for it. But we got to ask ourselves that little question. And I think everybody should say, no way, they're not the same. If you say, yeah, they are the same, you're in the right class, by the way. And when we talk about sediment, we're talking about the particles that either are deposited or suspended in water and air. So that water, brown water, is loaded with sediments. It's not just what's on the ground or in front of an inlet. What's sedimentation is just the process of depositing those things. How do you do it? And you say, well, we just put a barrier in front of an inlet. If anybody was in my class there, I trashed out inlets in front of a barrier pretty bad. They only work when it doesn't rain. If it rains, you got a problem with inlets, protections. So how do we minimize sediment? And that's not working. These are all the ones, if you think about it, you've probably been to, I don't know how many classes, and somebody says, oh, you got to do erosion control. That is exactly right. The erosion control's the least expensive BMP out there for controlling sediment. So be aware of that, and especially designers, when you do your plans, think about this. Timely use will make a lower construction site cost. It happens. It's been worked all over the place. Barriers to intercept runoff, sure. Silt fence, fiber rolls, we see them here. You're going to contain runoff. You have sediment basins, sediment traps, reduce flow velocity. All these are the barriers. But if you notice, there's just really a very few techniques out there. And somehow we got to get it so we can model about that as much as we can. But if we continue to use fiber rolls, silt fences, they're costly. Maintenance cost. You can ignore them, but there's something called the Environmental Protection Agency that's going to change it, and something called HAR, 55 I think it is, and stuff like this. So you got to be careful on all these things as we go through. Your water erosion, wouldn't you like to be going at midnight down that road one time? It's just the particles displaced by action of wind and water. Know those three. If you know those three, you have now solved 50% of your problem. And it may sound like a stupid thing to say, because if you can control erosion, you're controlling sediment. Simple as that. True or false? True or false? How many say true? How many say false? How many don't give a rat's? Okay, it's false. Nearly all sediment control BMPs are very, very ineffective. The only one that's effective is a set pond, which on a highway project, you got what, 1 millimeter this side of the toe that you have to work on there? But you actually have other places within. You ever thought about using the median of a highway you're building to be a temporary set trap? Just some thoughts as we go through. So we got to look at that very carefully. Just to go through, some of you may have seen this many times, wind erosion, That itself is something there that we like to talk about, because if you think about Oahu, the west side of Oahu is a heck of a lot drier than the east side. Wind erosion can be much more of a problem on the west side than on the east side. Well, these are illustrations. We call it siltations, suspension. You might have seen this in the news when Phoenix, Arizona got hammered. By the way, notice this picture from the Sahara Desert to South America. Amazon is built by the soils from Sahara Desert. Creep, it's not your boss. It's a sand moving all over the place. Which one transports the most? How many say suspension? I know all of you talk. You did out there a minute ago. Which one do you think? Well, I'm glad that you asked that, because siltation's the biggest one. For every particle goes up, comes down, it dislodges other particles. They go up, they come down, and get that type of deal. So there's a lot of things that we just want to talk about. There we go. This is the one you're interested in, raindrop erosion. Without a doubt, one little raindrop can do a heck of a lot of damage. Try picturing millions of raindrops coming down to a storm event. Then you got sheet erosion, where just water flows over the land. Of course, you got to have flat land. Hawaii has a lot of this instead of this, doesn't it? Well, that, when it's flat, can also create a lot of erosion. Then you got rill and gully erosion. There's 40 rills in that one, the rills being about 3 inches deep. And when you talk about the rills and the gully formations, usually a rill precedes the gully, depending what type of soils you have and so forth on there. But did you know, if you happen to have a 3 inch by 3 inch by 22 foot long rill, you're gonna lose that much soil, get 184 of those rills, you can fill up a 9-yard truck very fast. Very fast. And I think all of us have seen this out on a construction site, haven't we? And if you haven't seen it, that means you're either doing a wonderful job or you've been asleep when you went out and looked at the construction site. One more storm event. This was one event. And by the way, this was only a 2.6 inch rainfall event. That's a major rainfall event for us. That's about 1/5 of all of our total precipitation in Colorado. One event, that was the erosion control product specified by the designer. Straw bales, which you don't have and don't get them, and don't want to even go near them. They're terrible. But again, look how much a gully, 3 foot by 3 foot by 23 foot, you can fill up a 9-yard truck. This was all set to be rip-wrapped. Contractor decided, no, I'm going to wait to the end of the project. Boy, did he lose some money on that one. Stream and channel erosion. You saw the talk today. That was a big Thompson flood. This was the result of it. How would you like to own that car? Try to back out on that one. Got shoreline. Got landslides, debris flows, and you have geologic right over in Kauai. All these are a result of erosion. So if we go through on this, we talk about this thing for minimizing it. Remember, all of these things that we can talk about in water erosion, they're all products in the toolbox. Make sure you get familiar with them. Understand them. Don't just listen to the distributor saying, this is the product that you need right here. Ask that distributor, where do I not use your product? That is far more important than where do I use your product? Because they're going to sell everything they can to you. And I don't blame them. They got to make money. Yeah. Okay, there are a couple models here we're going to talk about. You might have seen these, universal soil loss equations. It's been superseded by the revised universal soil loss equation. Then we have mussel, which is the modified universal soil loss equation. All of these came and started, well, RUSLE and mussel started about late 70s. In late 90s was the new one that came into here, much more accurate. But we got to ask ourselves, what causes erosion? Well, rainfall, right? Definitely rainfall. Soil erodibility of the soils themselves, that's definitely going in there. And you got to look at the soils, and your soil scientists, you can have all the fun, all you want with that. All part of it. There are other ones we need to know is how far does the water flow? Then the other one, and it's the most important one, is the angle. Steep slopes are disastrous for you. Flat slopes, we love them in Colorado. We got them. We also have steep slopes. You got steep slopes, and if you're putting up a little fiber roll up here, you just lost the battle big time. There's no way in heck that you're going to be able to do anything except watch the sediment go into the Pacific Ocean. So you got to be careful on these things. That's a critical parameter. This is what you're trying to design your plans for. This is your BMP. What are we doing for erosion control? What are we doing for sediment control? Where do we put it in? How do we put it in? When do we put it in? That's designers, your responsibility to work with the contractor. And by the way, I have another nasty thing to say. Designers, you should always go out to the construction site, especially when it rains. Find out what the real world's all about. It's different than when it's all dry. This is the universal soil loss equation. Empirical relationship, been around since, like I say, the 70s, where we talk about all the annual erosion rates and rainfall factors and C factors and P factors and XYZ factors, whatever you want in there, we got them in here. There's the revised universal soil loss equation. Same thing, isn't it? What has changed is better accuracy on rainfall, better accuracy on erodibility, and so forth on down the line. So we go and look at these things a little bit. They have maps for you in Hawaii. Thank goodness. And on Oahu, here's Pearl City, right? Or Pearl Harbor, down into here. You got all this number 100 or I think it's 150, I can't read it from here. But look between here and here. If you're building over here, look out. Rainfall's gonna hammer you. You're over here, you've got a lot of leeway, but not a lot that you can rely on, but you say, I can have other measures to deal with here because it's more of an arid environment over here. I'll show you what I mean by that. Erodibility of the soils. It's built on the silts and sands and so forth on down the line. But anyway, we got the situation on there where we just have a number. It's just a number to work with. That's all it is. And it's based upon all that stuff you see on the top part there on the right-hand side. And the erodibility of the soils, if you look at it, clay's the least erodible. Not the most erodible. But as soon as you disturb those clays, man, they're hard to control. You're probably up around, I'm thinking up around between the sandy or silty clay loam, somewhere around in there. It's going to vary throughout the islands. But just remember, I think you heard this number today, how much erosion can occur. Silts are 35 times more erodible than clays. And those are all things that we have to be careful with, and that was that 0.5 where it came in. They have something called topographic factors, and it talks about the slope of the land and how far water flows, and there are nice magic numbers. There's whole empirical relationships that got in there. I don't give a darn about them, except to think what happens when the land slopes are doubled. And if we take a look at the potential, and this has just been a mathematical equation on here, and if we happen to take, say, a 10% slope going up to a distance of about 32 feet, and we look at that and we say, well, that's only about 1,600% increase in sediment with flat land. You go over here and double this slope, you end up seeing that you're going to get 26 times more erosion on a steep slope. This is why I say always, always do erosion control on your projects, not at the end of the project, during the project. And it can be done. It will actually save money in the long run. Now, what happens if the flow path is doubled? Now, we go from here, from 25 meters or 32 feet, in that case, going all the way up to 50, 6 times. Slope is your killer. You like flat lands, that's fine. But if you have slopes in there, and occasionally I understand that highway departments work on some steep lands around here, occasionally. So be careful with it. These are all part of the modeling aspect of it. So basically, remember, when you're dealing with erosion, you're modeling it, it's more impacted by slope than it is by how far water travels. They have something called C factors. C factor means that's erosion control. They have P factors, that's sediment control. And when we talk about a C factor of, in this case, let's say 0.30, it just simply says that the vegetation is 70% effective in reducing sediment and erosion. Use it to your benefit. It helps you out. But if we talk about a P factor of, say, 0.75, the opposite's occurring. It does not say that 75% of the sediment's contained. It says that 75% bypasses that structure. These are the things you got to be aware of in modeling. And where did all the sediment go in that particular one? Right into that inlet, which is exactly happens on every one of your storm events right now out here. So these are this important things. If you were to map these out, notice what it is with dense pasture grass in there, and you remove that sediment based upon the erosion rates that occur by RUSLE, and then you put on some type of cedar mulch. Look what you're doing. You're knocking it down by 93%. That means you don't have to have that intense sediment control. It works. It really works. They have, for calculating how much sediment's associated with it every time, they have something called the modified universal soil loss equation. Again, I'm going through 3 hours in less than 10 minutes now, right? Pretty close? Yeah, 10 minutes. Okay, well, I know you're all impressed by what you see on there. V, by the way, is the volume of water that comes off the watershed. Q is the peak flow. What does that conjure up as far as as a designer? We got to do hydrology for this site. We cannot just put a barrier here and a silt fence there or fiber roll over here. We got to know the hydrology of our site. What a concept. Why? Because sediment is associated with runoff. You got to know these things. That's why they say, get us the discharge point. Find out what happened. Get your calculator of your volumes. And these are all things that we do in other classes that we have in there. This is the SCS curve number method and so forth on down the line. We're not going to cover it today. We don't want to get you too excited about having to do math in this class today. And you wouldn't want to do it anyway. So, but take a look at what we have here. If we were to take the modified universal soil loss equation for a single storm event compared to revised universal soil loss equation, which takes it for 10-year, 24-hour storm event, we can find out that the shape of potential sediment yields looks about the same as it did when we did the erosion rate aspect of it. But again, look what happens. 91% by this calculator per one storm event. Well, if you compare the two, they look kind of the same, don't they? They have the same ups and downs and bumps and everything. The bottom one looks a little bit different than the top one does when we have disturbed lands with weeds on it. Weeds can, not the other type of weed, but weeds that grow naturally, it's legal, is an erosion control product. But boy, you don't want that stuff on there. You want to get a good establishment of vegetation on here. Well, the one up above there for modeling by RUSLE, everything's based on a 10-year, 24-hour rainfall event, statistically looked at over for 20, 40, 50 years, I think it is now. Whereas MUSLE is a single runoff event. But why aren't the shapes exactly the same? I mean, we got something relatively speaking, but boy, that one with the weeds is really different, isn't it? Well, it comes from the fact that Revised Universal Soil Loss Equation has done a lot more work now to figure out what some of the parameters are, whereas the ones associated with the Modified Universal Soil Loss Equation has a variable a lot of people really are not looking at very closely, and that is the fact that you've got to do hydrology. How much runoff do you get for that 10-year, that whatever storm event you're modeling? So hydrology is a critical parameter that every designer needs to do on every SWIP that they generate. Because if you don't do that, you're not going to get a very good handle on what the modeling aspect of it is. So, I'm right on time, aren't I? Do I get a gold star? Good. Conclusions. Remember this. Modeling rates and sediment yields, not an exact science. And if you remember that, you're going to be in good shape. Most important one is right here. If you happen to do a calculation with Revised Universal Soil Loss Equation or with Modified Universal Soil Loss Equation and say, I have, coming off this site, 35 tons of sediment. Do not ever go to court with that particular number. You will be eaten alive by every attorney in the world. It's not exact. Why isn't it exact? Is hydrology an exact science? Anybody who's ever done hydrology, you take some numbers over here, well, it's a CN number over here, we're going to use that number over there, we've got a slope length here. I like to make it do 230 feet. Oh no, I like 250 feet. No, it's got to be steeper. Everybody in this room can have a different value for a peak flow. It's not accurate. But it's the best we have. Erodibility, it's not accurate. But it's the best we have. Use it to compare. And that's what you need to do in this thing, is take the results that come out of whatever you generate from whatever modeling you have and compare what would it do if I put in erosion control? What would it do if I put fiber rolls in? That's the beauty of modeling. But do not assume that the results are absolute by any means, because they're not. And as long as you keep that in mind on modeling, you'll be in good shape, because that tells us that you in turn are generating everything you need to try to understand the situation and try to understand what happens when I put BMPs in an effective manner throughout the construction cycle, not at the end, the limitations of those BMPs. This says basically you got to know those products. You got to know how to put them in. You got to know where to put them in. That's the responsibility of every designer in this room today. That's also the responsibility of every regulatory person that's in this room today. And when you go out to the site and you can talk to the contractor, ask him, hey, does this work? If he says, no, it doesn't work, why did you put it in? Because you had one of the plans, I can't get the change order through real quick. What is it next time you can do to make it better? If you do those things, you're going to be the best designers in the world. Thank you very much.